Hi, welcome back. Today we're going to do the next question in this series of stack question, which is to evaluate the reverse Polish notation. So we are given an array of string tokens that represent an arithmetic expression in an RPN. So some context on this, basically it's arithmetic operation whereby the operators follow the operands, right? So for example, we have plus, minus, multiplication and divide, and then operand may be an integer on another expression, right? And then the division between two integers always truncates towards 0. There will not be division by 0, and the input represents a valid arithmetic expression. Okay, so they help us by telling us there is no division by 0 in this case. And yeah, I guess let's take a look at some examples. So in this case we have 2 and 1, right? And then followed by 3 multiply. So this is quite a challenging question in terms of understanding, but no matter, we will try it out. We have 2 plus 1 times 3. So this is how 2, 1, 3, followed by 3, followed by multiply, right? And then here, let's try without looking at this, okay? So 4, 13, 15. 4, 13, and 5. So in this case, I believe that 4 and 13 must be grouped together, and then wait, no, it comes out first. How do we evaluate this? So the first thing we have is we have operand, right? And then we have 13 divided by 5, and then once we have that, this entire operation will multiply by 4. Okay, so I believe the way we look at it in this case, right, is that we want to see when there is a operator, the preceding two operands will be used. So let's see if this makes sense, right? So we come here, this is an operand, right? And then this is an operand, and here we have an operator. So we want to use the previous two operands, which is 1 and 2, combine it together to form an expression, which is 2 plus 1, right? And then here we have 2 plus 1, and this is all done. And then we have 3, which is an operand. We ignore it, and then we come to multiply, which is operator. Operator will use the previous operand and the previous operand. So this operator will be 3, and then 3 multiplied by this expression, which is 2 plus 1. Yeah, I guess that's pretty. Let's try this again. Let's see if we can write this out myself, okay? So let's take this as an example. 10, 6. 10 and 6 is an operand, so let's just ignore it, add it to a stack, right? And then we have, I'm really going a little bit into solutioning. So we have 9 again. Again, 9 is an operand, so let's just ignore it. 3 is an operand, let's ignore it, add it to a stack or somewhat. Okay, here we get plus. So the first thing we want to do with plus is we want to check the previous two operands. We want to pop it twice. 9 plus 3. So this translates into 9 plus 3, right? And then 9 plus 3 now becomes an operand. This thing here, this stack becomes here. 9 plus 3 becomes an operand. It becomes an expression within the stack. And then since this is done, now we have negative 11. Negative 11 again is a operator, right? Is a operand. An integer, and then we have multiply. So this multiply comes here. What happens to multiply, right? So multiply will take the previous two. So it's 9 plus 3, which is 12. 12 times negative 11. 12 times negative 11, it's 12 plus negative 11. This part gets popped out again. We have, let's do this from the start again. So initially it's 10 plus 10, 6, 9, 3, plus, then this becomes like that, right? And then 10, 6, 9, 3 plus negative 11. Negative 11 becomes multiply. Then let's move this down. 10, 6, 9 plus 3, 9 plus 3 plus 3 multiply by 11, right? And then now we have another operator, which is a division, right? So now we want to take a look at this one and this one, right? So what we're looking at now is 9 plus 3 and 11 divided by this. So we take this, we have 10 comma 9 plus 3 divided by this divided by 6, right? We want the first one to be, wait, let's think about the order. Should it be 6 divided by this, or should it be 9 plus 3 multiplied by this? If I'm not wrong, it should be the last operator followed by the first. Let's take a look at this, right? 4, 3, 5, all right, divide. So this case, what we're expecting here, is it 5 divided by 13, or are we looking at 5 divided by 13, or are we looking at 13 divided by 5? So I believe here it's 13 divided by 5 and then plus 4. So 4 goes in front. 13 divided by 5 plus 4. Okay. So we gotta adjust our thinking a little bit. So this is 10, 6, 9 plus 3 multiplied by negative 11, right? And then here we have division. So this division should be 6 divided by this answer. So yeah, 6 divided by this answer that we have here, right? And then now we continue. We have another multiplication operator. So this multiplication operator will just come in here, remove this, and then we have 10 multiplied by this operator, right? And then 10 multiplied by this operator. Next one is 17. 17, we will add it to the stack. 17, and then we have plus. So this is 17, this one plus 17, right? And then we have this one plus 17, and then we have 5. So we add 5 again, and then plus. So it's 5, this thing plus 5. Let's check if this is our answer. 10 times 6. Let's see if we got this correct. 21.5. And we rounded it up, right? Truncates towards 0. Let's see if I understood this correctly. So this is 10 plus 5 at the end, yes, plus 17 here, right? And then we have our brackets to have the entire operation. Let's see this. This on the other hand is 21.5 as well, yeah. So yeah, I think I got it right. The answer had a little bit of brackets here. Yeah, so 10 times 6 divided by the 9 times 3 minus 11, yeah, that's times negative 11. This entire operation needs to be 6 divided by this entire operation. 6 divided by negative 1, 2, 3, this is 0, right? And then this is 10. Yep. Okay, so you see how we did this just now in a fashion without a concrete example, but we have to think about how we can use a stack now, right? So first thing, I would suppose we would require a stack, right? So stack equals to this. We initialize the stack to be a push, append, and pop, right? Append and pop operations. So when we loop through the entire list of tokens, we want to make sure that if we come across a operator, we wanna make sure we use two preceding operands. When there is an operand, add into the queue, right? So first thing we want to do is we want to have operand set, right? So we have operator set, right? And then yeah, once we have a set, we want to make sure that's set off, right? Let's get a little bit of help here, do some googling, right? And then we have these, right? Operands. And then we have this, right? Let's do this, boom. And once we have this, a set of all the valid operators. And then the next thing we have here is the stack, right, of operations. Result. I'll just call it result, right? And then we have result stack to make sure it's clear to the user, right? And then we loop through the entire array for char C in tokens, right? If C is invalid operators, do something else, we want to do it, right? Dot pop operator 1 equals to operator 2. And then we return the result, right? We want to combine these two operations. Else, if C is not invalid operator, what we want to do here, and then you want to continue, right? You want to do something to this. Pop result stack dot push operators. And then okay, so let's yeah, now we have a result here. Result of operand 2. We have operand and operand 2. Operand 2 will be the one below, operand 1 will be the one on top. So we want operand 2 and operand 1, right? Result operation, mathematical operation. Math operation result to operand 1, right? So self.math operation, here we want to define this def, right? Math operation that takes in operand 1, operand 2, so it's basically takes in 2 strings, right? they're all integers, right? So this one, it's a string, right? It's a str. So add this in, add this in, add this in, and this math operation we want to return, right? What do we want to return in this math operation? We actually want to return an integer, correct? So in this case, what we want to do is we want to operand 1, operand 2, and then we want to see operator. We want to make a case for operator. And with a little bit of help, else if else, right? We have this operator is this. If C is invalid operators, we want to do this. This is a string. Yeah. Okay, so we want to check first if right. This, and then we want to do return all are integers, right? Integer that represents the value of the expression. This is int, right? And then they said that all the operands may be an integer or another expression. Okay, so it doesn't really matter, right? Okay, so it's just that. So essentially we just repeat this 4 times, right? If elif, and then we have a minus, multiplication, division, right? We have all of these here, and then it guarantees that the operator must be one of these, right? One of these. This is a plus, this is a minus, this is a multiply, this is a divide. Math operation, right? Then we do math operation, operand 2, and then we do C. The order here is important, right? Self, result dot append, result. Okay? And then else if C is not invalid operators, right? Result stack dot append C, right? And then once this is done, we have the entire result stack completed. We have one result we want to return. It should have only one result at the end of everything, right? Return result stack 0. Okay, this should be the solution. Let's take a look at some of my examples. Let's take a look at this very complex example, okay, to make it, and then we will run the code once. So firstly we have 10 and 6, right? So 10 is here, it comes in here. 10 is 10 in tokens. For C, this is 10, right? And then we see if C is invalid operators. Nope. So 10 comes in. My stack now is 10, right? Let's do this. Track this down, right? And then we have 10, right? Same thing goes for 6, same thing goes for 9, same thing goes for 3. Now we come to plus. When plus operand 1 equals to result stack dot pop 3, result stack dot pop 9, 3 and 9, self.math operation, 9 first before 3, so 9, 3, C here in this case is a plus, so it's 9 plus 3, you get this, 9 plus 3, yep, and then we have 9 plus 3 here, append result, 9 plus 3 is 12, 12 is here, 12 will be appended, done, right, and then we have 12. We are moving on to the next, which is negative 11. Negative 11 comes into the stack. Again, negative 11 comes in, exit the loop, result stack dot append this, result stack dot append C, continue, right? And then we have C, it comes in, comes out, append, result dot stack dot append, sorry, where was I? Yes, now we are at here. When we have this, it comes in, it comes out, we have basically 12 times negative 11, it's I believe 120 plus 12, 132, negative 132, right? So that would eliminate that. We have division now, so it's 6 divided by operand 2, operand 1, 6 divided by 6 divided by yep, that's it. Yeah, we have this, and then 6, sorry, we have a division, 6 divided by this is equals to 0, right? We have the self.math operation, 6 negative 1 3 1, 1 3 2 comes in, 6 divided by this is almost 0, so it will round down to 0, I'll pop it in, and we have this 0, correct? Okay, and then now we have multiplied, 10 divided by 0 is 0 again, right? And then now we have 17 will be appended to the stack, we have plus 17, 0 plus 17, we get 17, and then we have 5 is appended to the stack, 17 plus 5 is 22, and we're done, right? Beautiful. Let's try this, see if there's any errors we have. If C is invalid operators, takes 3 positional arguments, but 4 were given. Operand 1, operand 2, operator. Operand 1, operand 2, operator. Self.math operation. Okay. With reversed operators, C. And that should be it. I'm pretty confident in this idea. I guess there is some error management that we can do here. Else, right? Yeah, I guess return 0, right? Yeah, but this essentially is the idea. And oh, wait a minute. Oh no. String dot. What is the problem here? What is the problem here? What is the problem here? What happened here? Oh, 18 is not a valid value for a return type integer. Okay. Oh, it's just one. Okay. Let's just. Do we do this? Yep, that's all. I guess we just needed another operation here to make sure that a single operation itself and in single integer operand is also a valid reverse Polish notation. And that will be all for this question. It was surprisingly manageable to tackle because I have a bit of experience in this, I guess. Also with the hint of it being a stack question. And that will be all. Thank you for tuning in today, and it's on to the next question.